They may sleep for centuries, then wake with a terrible fury.
Mass destruction, terror. We want to get out of the way as quickly as possible.
Their power can burn, crush, and bury.
Imagine a wall of mud and rock 30 feet deep coming through this area.
This is the story of how volcanoes rise from the earth and the different ways they have threatened life on the planet. This is the science and the awesome power of deadly volcanoes. In the last 2,000 years, more than 250,000 people have been killed by the lethal weapons in the deadly arsenal of volcanoes.
There are lots of ways that volcanoes can kill you.
Several hazards include toxic gases and mixtures of hot rock and gas that come tumbling down the volcano.
A lot of times the ash that falls out of the air and covers things, particularly if it's wet, it'll collapse a lot of buildings. Mud flows can cause a lot of devastation.
Pyroclastic flows are in particular quite dangerous. These can result in the combustion of material that it encounters: wood, vegetation, houses.
Volcano victims range from individuals to whole species in mass extinctions. There are at least 10 major ways volcanoes cause havoc and kill. At number 10, lava.
Growing up, lava frightened me because it looked really hot. And I just thought of what that might do to someone.
When we get rock hot enough, it glows and gives off light because they are so hot. Dull red would be about 1,600 degrees Fahrenheit. And that's the kind of glow that you see on the burner of your stove. As it becomes progressively more orange, it gets up to around 1,800 degrees Fahrenheit. And when it gets a yellow color to it, it's up around 2,000 or 2,200 degrees Fahrenheit.
Above ground, it's called lava. Deep in the earth, the same material is called magma.
Magma is simply molten rock with gases dissolved in it.
Magma or lava, its ultimate origins lie 3,000 miles below our feet. The Earth's core is a radioactive ball bigger than Mars. More than 4,300 miles across, with a temperature of over 11,000 degrees Fahrenheit, hotter than the surface of the sun. Although heat from the core is reduced as it rises through the Earth, it can still top 2,000 degrees in the mantle. There is a constant battle between heat trying to melt the rock and pressure trying to hold the rock together. Almost everywhere, pressure wins. But in areas near the surface, pressure can lessen, and rock can succumb to the heat.
Within 100 miles or so of the surface, then this heat begins to melt rocks, and the melted rock, or magma, then rises up to the surface.
Magma, containing metals like magnesium, iron, and aluminum, plus oxygen, carbon, sulfur, and silicon, is less dense than the surrounding rock. It's lifted up buoyantly, sometimes with enough force to break through the Earth's crust.
If magma from the mantle migrates up into the Earth's crust, it can cause the crust to melt.
Flowing out of a so-called hotspot, batches of magma repeatedly rise, fall, and cool, creating layer by layer mountains, islands, and volcanoes.
There are several main settings where we see volcanoes erupting. One is at a hotspot location where the mantle is abnormally rich in melt, and that's the case under Hawaii.
Hawaiian volcanoes are the result of tens of thousands of eruptions over hundreds of thousands of years.
Lava rising from hotspots is fluid, broadly spreading around the vent to form a shield volcano.
They're called shields is because they have very low slopes and they look like an overturned warrior's shield.
In any volcano, as gas-filled molten rock rises to the surface, it creates an ever-growing reservoir called a magma chamber. As this pool of bubbling rock grows, the pressure builds and the chamber becomes a prison from which the magma strains to escape.
If you shake a soda so that the gas is coming out of solution in the soda, but the gas can't go anywhere, and then you open it up, then the gas pushes the soda out with it, sometimes quite violently.
A 1977 eruption in the Congo proved how deadly molten lava can be. The volcano was Mount Nyiragongo, an 11,400-foot tower with a seething lake of lava in its crater.
Nyiragongo produces very, very fluid lava flows. Basically, the volcano fractured and the lake drained out the side of the flank of the volcano very rapidly. And so it's a large volume of lava moving rapidly.
The lava was clocked at an astonishing 60 miles an hour. At least 70 people were caught in its searing flow.
These flows actually buried some elephants, so they found some rather gruesome molds where elephants had been overcome by the lava. The chills around them, and then there's the skeleton of the poor elephant.
In 2002, Nyiragongo's lava flowed again, destroying 12,000 homes and killing more than 100 people in the city of Goma. Lava isn't always fast, but it can be relentless, as one town on the Big Island of Hawaii learned in 1990. There were more than 100 homes in the community of Kalapana. They were targeted by one of the world's most active volcanoes, Kilauea. The lava kept coming, slow but inexorable. For 6 nerve-wracking months, it burned houses and buried land.
We're talking about one normal-sized dump truck about every second of lava being delivered down. 60 feet of lava were put over the top of the town, and so it will never be the same in our lifetime.
What happened to Kalapana could happen again. Volcanologists on the Big Island also cast worried eyes up at Mauna Loa, the biggest volcano on Earth.
If you took the lava that's in Mauna Loa volcano, you could stretch it and go all the way around the equator with a pile that's almost a mile wide and a mile tall. There's that much lava in it.
Mauna Loa last erupted in 1984. When that lava spills out, the Big Island's biggest city is right in the potential path of destruction.
Hilo is mostly built on Mauna Loa lava flows. So lava flows can, under some circumstances, get all the way into Hilo. It has to be a long-lasting eruption to do so, but it can happen.
The key is to cool and therefore solidify the lava. This can happen in nature with rocks. A rock that's the temperature of the surrounding air can be 2,000 degrees colder than lava. At high temperatures, more than 90% of the lava's heat radiates up, not down. So the temperature differential can cool and harden the lava. Even a tree can sometimes have a cooling effect on lava. Although, unlike a rock, the tree doesn't survive the encounter. It burns down to its roots.
In some cases, in a big tree, the tree actually cools the lava and the lava adheres to it. And that's what I'm standing next to right here is a thing that we call a tree mold. This was a tree, the lava flowed